Hi, my name is Sarah Roth, and I will be doing a presentation about sense making. So, for my introduction, I'll be talking about what sense making is and my personal experiences with sense making in school. So, what is sense making? So, sense making is an understanding or making sense of a whole concept by use of phenomena, science and engineering practices, student ideas, and science ideas. And I used this photo of these kids with the magnifying glass because I thought it's a good way for students to use sense making by making observations. And I liked that it was in an outdoor setting to change like the scenery, help so they are observing different things rather than just being in a classroom to do observations. So my experience with sense making is most of it came from elementary school science class and middle school science classes. And for this, we used a lot of predictions and experiments, hands on activities, which also goes along with experiments. We did a lot of things going outside, and with our experiments, we did a lot of collaborating with peers, and then trial and error, which also I feel like it kind of all goes together because trial and error, usually with predictions, you realize that it's something doesn't go right, so you try again until you figure it out or at least learn something. And then I also used this photo because this looks very similar to what I did in school is we did a experiment with electricity to learn about it where we had to try to like um, use batteries to get electricity, which I thought was really cool. And in the previous one, that picture, the butterfly, I'll go back. We also did one very similar to this, or this reminded me of it, where we got to have caterpillars in the class and watch them go into the cocoons and go into butterflies. And throughout this experiment, we made predictions about size and measurements and what would happen next, along with drawing pictures. So, my big idea number one is phenomena. And what is this? So it's pretty much events that occur in a natural system that can be observed and explained by science. So I used this photo of a girl using binoculars to show that it has to be able to be observed. So I linked a video. This is a YouTube video, and it discusses like the definition of phenomena, uses examples, and one of the examples I like that it uses is the sun setting because that is something, it's a phenomena that can be observed. We see the sun setting and it can be explained, so we can give a reason to why it sets and rises um, every day. And then the next big idea is science and engineering. So, what is this? This is engaging in practices to help you understand how something works. Doing science through engineering helps to motivate and engage students in science. And I thought that this picture is a good example of that. You can see that these students are engaged, the teacher is engaging with them. And I really liked this picture as well because it looks like something in my high school that we did. Well, other people did in a different classes. They built robots, and we kind of got to watch that and see how that worked, which I thought was really cool. Here's another example of science and engineering. So this shows that these two kids are drawing out their ideas of like maybe what to build, how they want it to look, and then you can see that they started building based off the ideas. So I thought that was a really good example of science and engineering in younger ages. And then this is a link to a video, and it talks about science and engineering and things that go along with it. And some of the things I liked that it mentioned that go along with it is it should include what students know, how students think, and what students can do, which I thought was really interesting. So, big idea number 3 is student ideas. What are student ideas? So, student ideas use their prior knowledge and backgrounds to do critical thinking. They can use these thoughts and ideas to help problem solve and collaborate with other students. And I use this picture because it shows that students are raising their hands, they're engaged, and they want to talk about their ideas. And why are these ideas important? And it's because allowing students to use their own thoughts and ideas can keep them engaged and motivated. This will help them to understand topics better and build off of each other's ideas by collaborating. So in this picture, you can see that these two students are building something and they're working together, engineering something together to create something. So they are collaborating. And for my conclusion, I put that sense making is a very important aspect in helping students to learn. Sense making includes many important concepts such as phenomena, science and engineering, and student ideas. They are all very important for sense making, and they keep students engaged, motivated, collaborating, overall making sense of the topic they're learning. And I use this photo because it really just shows a hands-on experiment. It looks like they're maybe learning about sound and using sense making to understand the topic. And then I used this final picture to show that these students are engaged, they're wanting to share their ideas, and they're just seem to be enjoying the topic. They all look very happy. And then those are my references.